Okay, so you just watched a video from the Khan Academy people, and I'm going to do 2 examples with you of solving systems of equations using elimination. I want to refresh you that the first method was graphing, so we could solve for y in both of these equations and graph them and figure out where those lines are intersecting, and that would be our answer. Last week, we also talked about using substitution, and so we would get one variable by itself, solve for it, and then plug it into the other one. That works. And then now elimination also works. Okay, so the thing with elimination is we are literally going to choose a variable to eliminate. Okay, so we're going to stack them. Since these are pretty simple problems, we'll get to harder ones later in the week. I'm just going to draw a line because I know that this is going to work. But sometimes we're going to have to do a little bit of work on that, and I'll do a video of that probably tomorrow or Wednesday. But when you stack these, like x is on top of x, y is on top of y, number is on top of number, we want one variable to eliminate. And what you're going to notice is right here. What is 2x minus 2x? That is 0. That is also 0x, but we know that 0 times x is just 0, so we don't need it. It is gone. That is what we wanted to happen, okay? So it's eliminating like it says, and so then you add them. 3y plus y, you can stick your 1 there if you want it. What is 3y plus 1y? It is 4y, and then 20 plus 4 is 24, okay? So clearly now we're almost solving for y. We need to divide both sides by 4, and we get y equals 6. So good job, us. We got y equals 6. But we know that when we solve any of these systems, we're trying to figure out on a point, on a line where they intersect. So I've got y. What do I still need? X. So we are going to use substitution. So we're going to take this and we're going to plug it into y. And I'm going to tell you it does, write this down on your paper since you're working this with me, not matter which you plug back into. It doesn't matter. I can go into the top equation, I can go into the bottom equation, it does not matter. You did learn this in 9th grade, and maybe your teacher told you it did matter, but it does not. And so I'm going to choose to go on the top. I usually choose to go into the top. So I'm going to take this and sub it in for y. Remember, subbing in just means like we're totally replacing that y with that 6. So now I have 2x plus 3 times 6 equals 20. And I solve it, and so I get 2x plus 18 equals 20. Still solve it. I get 2x equals 2. Divide by 2 and get x equals 1. So I've done all this work. I found x, I found y, but what do I have to put? I have to write it as an ordered pair, as a coordinate point, however you want to call it. You got to tell me the point where these lines are intersecting. They are intersecting at the point 1, 6. So if you don't have that final part right there, you won't get the full credit. Remember, this is telling me a location on a graph, so the parentheses are required, okay? So if you need to pause me for a second and get all that down, you do need to be copying this down so you can reference it. You can always reference these videos back. But we are going to do one more together, okay, and have it written down right here. So go ahead and pause if you need to. So we're going to try to solve this one using elimination. And I know that in elimination, I want to stack the problems and try to figure out if one variable will eliminate. Well, 3x minus 10x, that's negative 7x. That doesn't go away. Negative 4y plus 4y, guess what? That one does. And so that is what we want to happen. And so we said 3x minus 10x. You just do the operation that's listed there. There is no operation here, and we know that if no operation is listed, we do add there. So we're going to have negative 7x equals negative 7. Well, I'm almost finished. I need to divide both sides by negative 7 to solve for x, and I get x equals 1. Okay, I have x. What do I still need? I need y. Okay, so this time I'm going to take this and I'm going to plug it into the bottom just to show you that it will work. I do think it's easier going in the top 99% of the time, but you can do the bottom. And so I have negative 10 times 1 because I've replaced that x with 1 plus 4y equals 12. Try to get far enough away. And so we have negative 10 plus 4y equals 12. I am going to add 10 over, where did I mess up? Did I see it? I made a mistake. And now that I see it, because this is not going to work, okay? So everybody look, this is a good learning point. What is negative 5 plus 12? It is not negative 7. And it's just positive 7. So then this is going to be negative 1. Does everybody see that? I made a mistake right there. Okay, I added wrong, and I knew I was going to add wrong because it was going to give me some weird decimal, and we're not to that complex of problems yet. So everybody sees my mistake. Negative 5 plus 12 is positive 7. So when I divide positive 7 by negative 7, I get negative 1. So now let me try to re-plug that back in. I get negative 10 times negative 1. And this is going to be hard. I'm going to have to put the phone down for a second. But this is going to simplify. Very clearly, we're going to simplify by 2 and get y equals, hang on. Y equals 1/2, okay? So again, I have x, I have y, but I've got to write it as that coordinate point. And so my answer is negative 1/2. And what does that mean? That means, like the guy showed you on the con video, that is the location that they are intersecting. So if you were to graph this thing, they would be intersecting like right there, something like that. Okay.